Hi everyone, Mr. Schleicher here, and I want to teach you on how to write ionic compound formulas. So like we learned about in naming ionic compounds, we know that in ionic compounds all the charges add up to 0. So in order to make sure that all the charges are adding up to 0, you're going to have to make sure you know the charges for all the elements in your compound. And you might want to look at the periodic table for this. So please remember, all these compounds are neutral. That means they add up to 0. There's not some overall charge in them. Whenever you're trying to balance everything up, everything has to add up to 0. So, I think everyone has their own method for solving problems like this. I'm solving this from scratch. I'm not looking at a key or anything. So this is just my natural process I'm going to show you. And whatever works for you, use that. But if you're looking for a method, here's mine. So whenever I'm looking at names and I'm trying to come up with the chemical formula of something, of that name, what I'm going to do is first of all, I'm going to come up with, what is my cation, what is my anion. So it looks like my cation is some sort of magnesium ion, and it looks like my anion is some sort of sulfur or sulfide ion. So when I look at my periodic table, I see that magnesium, well, that's just Mg. And I know since it's in group 2A as a 2 plus charge. So I'm going to write that down to help me think about it. We have Mg 2 plus. Actually, let me use finer font this time. Mg 2 plus. Okay, when I look at sulfur, I see that sulfide has a, it's in group 6A. So if it's in group 6A, it's going to gain 2 electrons and have a negative 2 charge whenever it ionizes. So sulfur is S2 minus. So this is what the question is. It's like, how many of each ion do I need for the ions to add up to 0? In this case, it's really simple. If you have a single one of these and a single one of those, they already add up and the charges cancel out and equal 0. So if I just need one of each, then I can simply say, hey, the formula of this is MgS. Notice that in the final formula, there are no charges. There are no charges in the final formula. All right? And if you want to double check your work, you can add up everything together. If we had a positive 2 plus a negative 2, then that is 0, which is what we wanted. Okay, that's a basic example. Let's try something like rubidium oxide. So next example here. Rubidium is our cation. Notice our cation is always going first, and oxide is our anion. So I want to do the same thing where I kind of look each one of them up, and then I try to come up with, what is the symbol and what is the charge. So over here, rubidium is Rb. Since it's in column 1A, all these alkali metals are going to have a 1 plus charge. So rubidium, let's say Rb with this 1 plus charge. In chemistry, we just normally say a plus sign. And then oxide, if we look over here, oxide comes from oxygen. Oxygen, whenever it ionizes, it's in group 6A, it's going to gain 2 electrons, and then it will have a 2 minus charge. So oxide is O2 minus. Okay, once again, I want to ask myself, what combination of these 2 ions are going to add up to 0? If I have one of each, that's just not going to work out. Rubidium has a 1 plus charge. A 1 plus charge does not cancel out a 2 minus charge. So in this circumstance, I think I'm going to need to double my amount of rubidiums in order to match that 2 minus charge. So the formula of this one is probably going to be something like Rb2O. And this will be my final answer here. Notice there's no charges in the final answer because they completely canceled out. If you want to check your work here, you can kind of add up everything, kind of like positive and negative numbers. I had -1 and I had 2 of those, and I'm adding it with a positive 2. So does that equal 0? I mean, yes, but if you want to do it step by step, that's just -2 plus 2, which is equal to 0. Okay. calcium nitride. This is probably where the examples get the most complex of all of them. Calcium nitride, once again, I really like coming up with my cation and my anion first of all. So calcium, it's over here on my it's over here in my periodic table. What is it? Oh, right here in column 2A. Notice it's right there. So if calcium's in 2A, it's going to be Ca with a 2 plus charge whenever it ionizes. Nitride sounds kind of cool. That's just going to be nitrogen, a nitrogen ion. And since nitrogen is in column 5A, it's going to gain it's going to gain 3 electrons whenever it ionizes. So nitrogen is going to have a 3 minus charge. A nitride ion has a 3 minus charge. Okay, this is where I ask myself, okay, what combination of 2 and 3, how will they add up to 0? How do they cancel each other out? So I think everyone has their own, strategy for this. I think a lot of chemistry videos and textbooks out there, they might say something like, oh, you just do this thing called swap and drop, where you swap the charges, and then what was the charge of one thing is now the subscript of the other thing. So, I mean, this helps you, like for example, Ca, the subscript for Ca might be 3. So someone might say that, and then they might look at N and they say, oh, well, the subscript for N is going to be 2, and that'll be N2. And that might be the correct answer, and if that's the best way you can do it, you should do it that way. However, I think conceptually, this is not telling you what's going on. What I think is better for you all to think about is what combination of each thing is going to cancel each other out and add up to 0. So this often will take a few more steps, but I promise it gets easier and it works for everything, every situation here. But you might ask yourself something like, what is the least common multiple? What is the least common multiple between these two numbers? Because that's going to be the total positive and the total negative charges that are canceling each other out. So just for review, y'all, the least common multiple is like the smallest number that both numbers can multiply up to. So just some examples here off to the side really quick to make sure you know what least common multiple is. When we say least common multiple, the least common multiple between 4 and 1 is 4, because 4 can fit into 4 1 times. 1 can fit into 4 4 times. The least common multiple between 5 and 3 is 15, because these numbers cannot fit into each other, but 5 can fit into 15 3 times, and 3 can fit into 15 5 times, and that's the smallest number they can both fit into. 6 and 12, the least common multiple might be 12 there, just because they can both fit into that number a certain number of times. And then over here, for our example up there, what is the least common multiple between 2 and 3? Well, it would be 6, because 2 and 3 can't fit into each other, but 2 can fit into 6 at least 3 times, 3 can fit into 6 twice. So the least common multiple is 6. So why do we care about the least common multiple? Well, that means that overall, you're going to have a positive 6 charge canceling out a negative 6 charge, a 6 minus charge in these ions. So you can ask yourself, well, how do I get a positive 6 charge? How do I get a positive 6 charge from, a positive 2 charge? And the answer is if you have 3 calcium ions. So let's do Ca3. And you can ask yourself, well, how do I get a negative 6 charge from this 3 minus ion? Well, the answer is you need 2 of those 3 minus ions to get to negative 6. So that's how I personally like to solve problems like this. This is Ca3N2. This is what calcium nitride's formula looks like. You can double check your work here. I'm going to stop double checking the work over here to the side because I think it's kind of redundant if you know what you're doing. But if you have 3 of these positive 2s and you combine it with 2 of these negative 3s, then that of course adds up to 0. All right, let's do our last example as well. Strontium carbide. Strontium carbide. Strontium, if we look on our periodic table, it's over here on the second column, 2A. So it's going to have a 2 plus charge, and the symbol is SR. Carbide, it looks like that's going to be all the way over here. It's actually carbon ion. It has a 4, it is in group 4A, and since it's a nonmetal, it's going to gain electrons to get a negative charge. It's going to gain 1, 2, 3, 4 electrons there. So it'll have a 4 minus charge. So strontium has a 2 plus charge. Carbide has a 4 minus charge. So this is where I want to tell you like why you can't just swap and drop all the time. If I swapped and dropped, what people like to say is, maybe I'll be like, oh, SR, the subscript must be 4, and oh, C, the subscript must be 2. Okay, this is actually incorrect. You're not allowed to have subscripts that can be reduced. So you'd have to reduce that in some way. If you use the least common multiple technique, you'd have to ask yourself, hey, what's the least common multiple between 2 and 4? Well, both of those numbers can fit into the number 4. So the least common multiple is 4, which means you have a positive 4 canceling out a negative 4 charge. So you have to ask yourself, hey, how do I get a positive 4 charge from a positive 2 strontium? Well, you need 2 strontiums, so I would do SR2. Then I can ask myself, hey, how do you get a negative 4 from a negative 4 carbide? Well, you just need one of these carbides. So you just need one there. We don't put a 1 as a subscript. That's redundant. And then this will be our final answer. Notice no charges in the final answer there. And that would be correct. So with our ionic compounds, we always use the most reduced subscripts possible. And least common multiple gives us that. Let's move on to this next example here. So what's really nice about this next section when you have variable metal charges is as long as you know the symbol of that metal, the name gives you the charge. So you remember, just like before, whenever we're trying to think of the charges, the total charges do have to add up to 0. And if you need more than one ion, then use a subscript to say how many they're going to be, small number in the bottom right. And here's a number one misconception. I think students get confused on this all the time. They forget how to do this and they misremember. A Roman numeral is the charge of the metal. It's not the number of ions you have. Okay? It means a charge. It's not the number of ions. You need to go in and do the work. You need to balance the charge. You can't just say, oh, that's how many there are. So for example, in gold 1 nitride, this is not the number of gold I have. It is not, okay? It is the charge of gold. So if you look up on the periodic table, gold is right over here. The symbol for gold is AU. So we're going to write AU when we're thinking about this. And the charge of gold in this one is a 1 plus charge. Nitride is N3 minus. We learned about that in the last section. So you have to ask yourself, hey, how many gold ions do I need to cancel out this nitride, this 3 minus ion? And the answer to that would be you probably need 3 of these to cancel out that 3 minus. So the correct formula for that would be AU and then 3 of them. So we do a little 3 in the bottom right and then N for nitride. So that is the correct symbol here. Notice that this number 1 had nothing to do with having 3 golds. Okay, you have to balance the charges there. Over here, copper 2 oxide. Copper, the symbol is over here. We don't have to worry about the charges because they give it to us. The charge of the metal is given in the Roman numeral. Copper is a 2 plus charge. Oxide is O with a 2 minus charge. I mean, this one seems pretty cut and dry to me. 2 plus cancels out 2 minus, so you just need 1 of each. This should just be CuO. By the way, be careful, y'all. Make sure this is a capital C and a lowercase u. I know there's lots of students, they tend to mess up the capitalization. Capitalization in these chemical formulas is very important. All right, next example here, we have tin 4 sulfide. Tin is over here. It is SN. Kind of an interesting symbol there, probably based on the Latin word. This is SN with a 4 plus charge. Sulfide is S2 minus. I think it's over here. You can see it gains 2 electrons when it ionizes since it's in group 6A. So you can ask yourself, hey, what's the least common multiple between 4 and 2? Well, the least common multiple would be 4. So you can ask yourself, how many tins do I need to get to 4 plus? And that's one of them.
Pardon for the interruption. I just want to remind you that today we do have detention in room 1240. 1 hour and 2 hour detention.
That is immortalized.
Room 1240. You should have your purple pass. Come back around to the front and you'll be able to get let in to go to room 1240 for those detentions.
All right, y'all, make good choices. Don't get detention. So we just said that tin 4, you just need one of these to get to a 4 plus charge. Sulfide, this S2 minus, how many of them do you need to get to a 4 minus? Well, probably 2 of them. So I would write S2. So the correct formula for tin 4 sulfide is SnS2. All right, this is a typo. I think nickel is, nickel is actually El. But in this next one here, we have nickel 1 carbide. So nickel is Ni. Since it had that 1, it is a 1 plus charge. Carbide is C. We said it was a 4 minus charge earlier.
We have one additional announcement. Those students who are interested in the Terra Costa internship meeting, it is happening in room 2222. You can come in through the very front, just show the pass on campus, and you'll be able to be let in. Thank you.
Sorry, y'all. I don't have time to cut out those interruptions from the video. I'm just going to upload it as is. But nickel 1 carbide, you might ask yourself, hey, what's the least common multiple between 1 and 4? And the least common multiple would be 4. So, how do you get a plus 4 charge from having a 1 plus nickel? Well, you need 4 nickels. So let's do Ni 4. 4 nickels is also known as 20 cents. Over here, carbide, how do you get a 4 minus charge from a 4 minus ion? Well, you just need one of them. So that'll be
those
C.
Of you interested in participating in the amazing, outstanding color guard auditions are today at 4 o'clock. So please, ma'am, please, sir, auditions for color guard are at 4 o'clock.
All right, they're having fun with these. So the correct formula for nickel 1 carbide is Ni4C. All right, titanium 2 chloride. Slight typo here, there shouldn't be a space between the metal and the Roman numeral. But titanium 2, if you look up titanium, I think a lot of people actually know this one. This is Ti, and this one has a 2 plus charge because the name told us the charge. Chloride is Cl, and we see chlorine is right here since it's in column 7A. It's going to gain 1 electron when it ionizes, so it will have a 1 minus charge. So you can ask yourself, hey, what's the least common multiple between 2 and 1? And that is 2. They both fit into the number 2. 2 fits into 2 how many times? Once. So this is 1 titanium. And 1 fits into 2 how many times? Well, 2. So you need 2 chlorides. And y'all, you don't need to narrate to yourself this the whole time, but I just want to really show you my thought process. And once you practice enough problems like this, they do come very, very naturally to you. Okay, the next section here is introducing polyatomic ions. So, as long as you're able to access a list of polyatomic ions, or if your teacher makes you memorize a list of polyatomic ions, what have you, you will have to recognize the name of a polyatomic ion and then kind of balance the charges and get to a chemical formula. By the way, non-binary just means there's more than 2 different things. Okay, so once again, total charges add up to 0, and you might have seen some of these examples before, but if you need more than 1 of a polyatomic ion to balance the charges, then the polyatomic ion, you just kind of put it in parentheses, and then you put how much of the polyatomic ion you want on the bottom right, outside of parentheses. So let's look at some of these examples. I do recommend coming up with the formula and charge first before trying to write the formula, formula and balancing the charges. So over here, potassium is K with a 1 plus charge, since it's in group 1A. Hydroxide, if you look that up, it's an OH with a 1 minus charge. So, if you're trying to balance these charges, it looks like you just need 1 potassium and 1 hydroxide. So you can just kind of smush them together to make the formula. The formula will be KOH. All right, next example, ammonium phosphide. Okay, ammonium, if we look that up on our polyatomic ions list, and just to direct you all to that, for this class, it is going to be on the back of your periodic table on the left here. So here's your list over here. So when we're looking up ammonium, we see here the formula is NH4, and the whole ammonium ion has a 1 plus charge. So this is NH4 with a 1 plus charge. Phosphide is a phosphorus ion. By the way, this is where people start mixing up names a lot. If something ends with "ide," most of the time it's going to be some sort of element. So you try to look at the elements list. The one exception was like hydroxide. Hydroxide, maybe that's the polyatomic ion that ends with "ide." If something ends with 8, then you probably look at the polyatomic ions list. There's no element ending that ends with 8, so you always look at the list there to figure out the formula and the charge. Okay, phosphide, we said look over here at the periodic table. That is phosphorus. Phosphorus is in column 5A, so we would gain 3 electrons to get to that charge there. So this is going to be a P with a 3 minus charge. Okay, so you just need to ask yourself, hey, how many ammoniums do I need to cancel out a 3 minus charge? Ammonium has a 1 plus charge, so I'm already thinking, hey, I just need 3 ammoniums to get to this 3 plus charge, which will cancel out a 3 minus charge. So in our formula, we would start writing NH4, and then since I want 3 of them, I'll put the whole thing in parentheses and then put a little 3 on the outside to show there's 3 ammonium ions. Then I know I just need 1 phosphide to balance out the charges there, so that's what I'll put right next to it. Actually, let me put it a little closer. There we go. Okay, next example here, ammonium phosphate. So we said ammonium was NH4 with a 1 plus charge. Phosphate, something that ends with 8, probably part of our polyatomic ions list. So let's peruse that. It's in the P's. What's nice is that this is alphabetically ordered. So phosphate, it looks like the formula is PO4, and then that entire thing has a 3 minus charge. So let's go ahead and write that down. We have a PO4, and all of that has a 3 minus charge. Okay, it looks like things are pretty similar here. You're going to need 3 of these 1 plus charges to cancel out a 3 minus charge. So I'm going to reflect that in the formula. We're going to say there's 3 ammoniums, once again. Oops, NH4. It's really easy to make simple mistakes here. So 3 ammoniums, and then a single phosphate doesn't really need parentheses. You can just write PO4. Now some textbooks and teachers might say, oh yeah, you should put parentheses around any polyatomic ion. It's kind of like training wheels. You don't really need parentheses if it's just one of them. Sometimes it helps you tell that it's a polyatomic ion, but most texts do not include parentheses around a single polyatomic ion. Only if we had 2 of them would I use parentheses. Looks like we have 2 more examples here, so let's finish up these notes. Gold 3 chlorate. Okay, so we know the symbol for gold is AU. How many golds do we have? Well, we don't have 3, so stop thinking that. The charge is 3. So each gold ion has a 3 plus charge. This one does end with 8, so when we're looking up chlorate, let's look up our list of polyatomic ions to figure out what in the heck that is. Chlorate, it looks like it's right here. Don't confuse it with chlorite. And it looks like the formula is ClO3, and that entire thing has a 1 minus charge. So let's kind of write that down, ClO3, and this whole thing has a 1 minus charge. All right, so I'm already thinking, hey, to balance the charges, this looks pretty straightforward.
Can I please have Valentine Akiti to the front office to leave? Valentine Akiti.
All right, so if you have a 1 minus charge here and you have a 3 plus charge here, I'm thinking, hey, you probably need 3 of these to get to that balanced charge status. Because if you have 3 of these, that adds up to the 3 minus charge, which adds up to 0 when you add it to 3 plus. Okay, so how do I show there's 3 of those in the formula? Well, you're going to use those parentheses again. So over here, write it in. Actually, I'll just write it right here for the purpose of this video. AU, and then we have ClO3. We want 3 of these ClO3s. So the wrong thing to do would be to put a 3 right here. That is totally incorrect. What we want to do is put this entire thing in parentheses and then put a 3 on the outside. And that shows that we have multiple of this ion. And this would be the correct balanced ionic formula there. Okay, let's do the last one here. Here we have silver chromate. Okay, silver is a very common polyatomic ion. It's kind of expensive though, but when we look over here in the periodic table, we did say we had to memorize the charges of these 3. Silver was always going to be 1 plus, zinc was always 2 plus, and aluminum was always 3 plus when they ionize. And you can kind of remember that based off of the fact that the group numbers are 1, B, 2B, and then 3A. Or the fact that they're kind of in this zigzag stair-step location, and silver is the first step, zinc's the second step, and aluminum's the third step. Silver symbol is Ag. It has a 1 plus charge. Chromate, this one's interesting. Chromate, we know it's a polyatomic ion because it ends with 8. But when we look at the list of polyatomic ions, chromate, it actually has a metal in there. That's really interesting. So sometimes your polyatomic ions can have like metals in them. So chromate, right here, the formula is CrO4, and then that entire thing has a charge of 2 minus. So let's write that down over here to make our lives easier. CrO4 with a 2 minus charge. So I can always think back to my least common multiple, or I can just think about what's going to cancel out what. If silver has a 1 plus charge, how many of them do you need to cancel out a 2 minus charge? The answer is probably 2 of them. So if I were to write the correct formula here, I'm going to write there's 2 silvers, so Ag2, and then there's a chromate, CrO4. And that's my final answer here. Notice I'm not writing charges. Those charges are not there anymore. They cancel each other out. They're balanced. If you write any charges in the final formula like this, that is wrong. You lose all the points on most standardized exams, including the AP test and college exams. It just means something totally different if you put a charge where it's not supposed to be. But anyways, that's all we learned about here. We learned how do you actually balance these charges. If you need to use the least common multiple, how do you do that? And then we could write formulas using these Roman numerals as well. They're just the charge of the metal. You just got to balance those charges manually. And then if you have a polyatomic ion, normally they'll end with 8, so you have to look them up then. And hydroxide ends with ide, and that's like the only polyatomic ion that ends with ide. Everything else tends to be just a regular element that ionizes. If you have any questions, please ask me or your teacher, and I hope you learned a lot.